in this problem, basically I would like to prove you that our old gate questions or gate upcoming questions, like they are of like very short and sweet. Okay, for example, this is old gate question only. Length of this question is this much. Okay, but you can get the answer like within one statement or one step. Okay, let us see here. Basically in gate, the important thing is we should be able to find out the keyword, the heart of the question. Okay, in this, see, single phase 10 kV, 50 Hz, 1 kV, blah 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 blah, something is written, and here 55 watts. Okay, no load losses. Now if you see, transformer has a core with all its linear dimensions √2 times corresponding dimensions of the first. In the sense, from first to second, my linear dimensions are increased by √2 times. Now means like remaining all we need not study. Okay, basically we have a minimum machine sense. What is that machine sense? Is going to be like flux density is not a term to play with. Okay, now forget about iron, let us think of copper. Okay, for example, if I want to inject 3 amperes, maybe this much area of cross section is required. Okay, if you want to inject maybe 30 amperes, area of cross section of copper should be increased. Now simple logic, if volume of copper is increased by, for example, x times, how volume of copper will be increased? Either by increasing area of cross section of copper or length of the copper, then only volume of copper will be increased. For example, if this is 1 mm square area of cross section, for example. Now for example, if I double this area of cross section of copper, what does it mean? I'm going to design a machine, or in the second case, with area of cross section of copper of double, means that my current capacity should be doubled, means that my copper losses should be doubled. Okay, so very simple, if volume of copper, if I increase, copper losses, will it increase or not? Yes. Then in that, what is the logic? In copper, current density should be constant. Okay, similarly here also let us map that to iron. Okay, with iron, normally here in copper, if flux density in copper current density is constant, and in magnetic material or core, flux density should be constant. Okay, now like after this, in the second case, my linear dimensions are increased by √2 times. So logic here is, see, if my length of the limb is this, area of cross section, if I cut it, area of cross section of the core is this. Now what he is saying, in the second case, linear dimensions are increased by √2 times, means that my length of the limb will be increased by √2 times, and each side will be increased by √2 times. Okay, such that in the new area of cross section will be, means each side is increased by √2 times. In this is total area of cross section of the core will be increased by 2 times. Side square is area of cross section of core. Now if it is the length of the limb is increased by √2 times, so in this case, how my volume of core is getting increased? Area of cross section is increased by 2 times, and length of the limb is increased by √2 times. So volume of the core, volume of core will be increased by 2 √2 times. If volume of core is increased by 2 √2 times, what about core loss? Should be increased by 2 √2 times. So means my core losses should be increased by 2 √2 times. So what should be the answer? In our previous case, it was 55 watts. So 2 √2 into 55 is going to be the answer. That is 155.6 watts. Problem solved. 155.6. So answer should be B. Okay. Anyway, people frankly don't listen. Let us solve the complete question. Is this designer problem or operating engineer problem? Designer problem, because area of cross section of the core is getting increased. So in the designer problem, complete equation should be considered. What is that equation? V equal to √2 pi f B max AC N. Now in this, if you compare from first case to second case, root 2 constant, universal constant, pi is going to be constant. Now about frequency, did they give any information? Yes, in the first case 50 Hz, in the second case 50 Hz. So frequency is constant, flux density we don't know. Now about area of cross section of the core. Area of cross section of the core is increased by 2 times because each side is increased by root 2 times. So this will be increased by 2 times. Now read the question. Like single phase 10 kV 50 Hz transformer with 1 kV primary winding draws 0.5 amperes 55 watts rated voltage, rated frequency, second transformer to root 2 times, and the core material lamination thickness are same. The primary windings of both the transformers have the same number of turns. So here number of turns are going to be same. Now in the first case, how much is the voltage capacity? In the first case 1 kV is the voltage capacity. In the second case 2 kV is the voltage capacity. So in this case voltage is increased by 2 times. Now voltage is increased by 2 times on left hand side, and right hand side also something is increased by 2 times. So flux density should be constant. If flux density is constant, how to calculate no load current? Basically my no load current of transformer will try to develop the flux in the magnetic material. So let us analyze magnetic circuit. So what is the magnetic circuit? Black is going to be first case and red will be second case. Now in the first case, this is going to be MMF, this is going to be operating flux, this is going to be reluctance of the core. Okay, so what is reluctance of the core? Is going to be 1 by mu naught mu r LC by AC. Okay, now let us see. In the first case my no load current is 0.5 amperes, and in the second case let us see how reluctance is going to vary, how flux is going to vary, such that if you know variation of this and this, you can calculate MMF, which is nothing but dot MMF divided by number of turns will be the current. Okay, now let us see what about my flux variation. What is flux? Is going to be flux density multiplied by area of cross section of the core. Okay, flux density is constant or not? Yes, flux density is constant. Now area of cross section of the core, like when each side is increased by root 2 times, so total area of cross section of the core will be increased by 2 times. So this is increased by 2 times. So means AC is increased by 2 times, means my flux will be increased by 2 times. So in the second case, let flux increase by 2 times. Okay, now let us see how reluctance is going to vary. Now if you come back and see this diagram, in this diagram area of cross section of the core is doubled, length of the limb is increased by root 2 times. So length of the limb is increased by root 2 times, means that total flux length will be increased by root 2 times. Now come back to here. Relative this area mu naught is going to be universal constant, and relative permeability is constant because he is using the same type of material. Length of the core is increased by root 2 times. Area of cross section of the core is increased by 2 times. Okay, so if you think of reluctance of the core, numerator is increased by root 2 times, denominator is increased by 2 times, so reluctance of the core should be reduced by root 2 times. Now flux should be increased by 2 times and reluctance is getting reduced by root 2 times, so my MMF should be increased by root 2 times. Getting my point, right? For example, let us think of it as a electrical circuit. In electrical circuit, current should be doubled, resistance is reduced, okay, by root 2 times. So what about the voltage? Should be increased by root 2 times, same way. Now what is MMF? MMF is going to be number of turns multiplied by current, no load current. So number of turns are going to be constant, he said in the question, and now MMF should be increased by root 2 times, means that my current, no load current should be increased by root 2 times, means that answer should be root 2 into, previously in the first case how much was the no load current? 0.5 is going to be 0.707 amperes. Okay, so by this what we can conclude, though length of the question is damn big, okay, one thing I'll tell you, IIT professors are not like, sadists or something. Okay, actually they will give a question, means for example we have done this much, okay, but simply if you are like, tension free, without any tension of like, fear of failure or something, so if you calmly think about it, means volume of core is increased by 2 root 2 times. So answer should be 2 root 2 into previous loss 55. Now if you observe the options, in the options 155.6, only in one option they have given C. Okay, means that if you can calculate 2 root 2 into 0.5, you are going to get the answer. Anyway, complete question is answered. Okay.